Quiz is on Monday, so today we're going to start something that's not on the quiz, exponent laws. But first we're going to finish up what is on the quiz, and perfect cubes is one of the things. Kids and I went on a Halloween scavenger hunt. It was quite fun. We did Crystal Green Drive, Ranch Road, Drake Landing, Cimarron. And then we had to go to Walmart and Dollar Tree to get, find caramel apples and, candy apples and caramels and sing things with eerie music. So we got them all. And the best thing we saw was we weren't even scavengering hunting. We were buying worms for our bearded dragon. And we saw a bearded dragon costume. So we're going to get it. It's sold out right now, but our bearded dragon is going to look like an elf. And Liz is actually going to love it because she loves when we put towels and I don't have a lot to do with the bearded dragon. But we adopted it from Mrs. Akira, whose kids raised it. You know, they were this big. We just saw a baby one. I couldn't believe it. They're like this big, and then ours is like that now. Big Avenger bearded dragon. Who's going to look like an elf? Can't wait. Okay, perfect cubes. We could fill in blanks to know the multiples, but it's mostly important that you know these numbers and the 1,000. I'm not going to worry about those ones too much. If you need to know that 7 times 7 times 7 is 343, well, then you need to know it. You can use it on a calculator. However, these are going to be the main ones. It's going to be the exact same steps as what you just did on your quiz. Simplifying radicals, except for instead of using the perfect square chart, we're going to use the perfect cube chart. Instead of getting square roots in your answers, you're going to get cubic roots in your answers. Okay, so it's a touch different, and we're going to use this chart, which I'm going to write along the side once I move this up. Okay, so the exact same steps. So it says right here. And there's not going to be as many of these. There'll be a splash of them. It's mainly going to be on square roots, what you just wrote. But I'm certainly going to throw some cubic roots at you, and so we'll grade 11 and 12. Okay, so these are the numbers we want. 2 times 2 times 2, 3 times 3 times 3. What's 4 cubed? 4 times 4 times 4? Good job. 5 times 5 times 5? And everyone knows what 10 times 10 times 10 is. There's 3 zeros. Okay, so lots of perfect cube chart that we're going to be using. We're going to put the perfect cube first. And that turns into a number. Write that down, please. Again, this is the same steps as we've just been doing. Just a different chart. Same steps, different chart. You can see that 6,000 is going to be 1,000 times something, so you break that up into the cubic root of 1,000 times the cubic root of 6. So break up the radical. Next step, turn your perfect cube into a number. What's the cubic root of 1,000? What number times itself 3 times equals 1,000? 10. And now you're good to be looking weird. That's a weird looking answer. That's the answer. 10 cubic root of 6. That's all you can do. You simplified it. And full marks for 10 cubic root of 6. Don't forget to put the cubic root, because we're used to dealing with square roots. These are cubic roots. So you need to put cubic roots. Okay, well now we got fifth roots. Why do they do that to us? Oh well. Fifth roots, obviously I'm not going to ask you 6 to the 5th, but you already know what 2 to the 5th is. What's 2 times 2 times 2 times 2 times 2? Somebody, or just punch in your calculator. Here's your calculator key right here. This is a very important calculator key for the next 3 years. 2 exponent 5. So put in 2 to the 5th. That exponent button, the little hat, you're going to be punching in for many times in the next 3 years. Okay, so what's 2 to the 5th? hopefully it's a perfect cube, one that we can use. Otherwise, we gotta go 3 to the 5th. So 2 to the 5th is 32, and we know that 320 is 32 times 10. So now we're dealing with 5th roots. And the perfect 5th is going to be turning into a number. So again, what's the 5th root of 32? Go ahead and practice for the quiz. Calculator, 5th root, 5 math 5, 32. One number multiplied by itself 5 times equals 32. 2. So this answer is 2, 5th root of 10. Yikes. I agree. It's awesome. Now, cubic roots are not just the red numbers. They can be negative as well. Okay, remember, you can take cubic root of negative numbers. So you can use the cubic root of 1,000, or you can use the cubic root of negative 1,000. Okay, so when you have a negative, your cubic root is going to be negative. So let's break this up into 2 cubic roots. One's a perfect cube. And what number are we going to use to get 16? Well, there's only one number less than 16. 8 times 2. We're not going to use 8. We're going to use negative 8. So negative 8 times 2 equals negative 16. And now what's the cubic root of negative 8? What number times itself 3 times equals negative 8? Negative 2 times negative 2 times negative 2. So this negative 2, cubic root of 2. Go show mom and dad this stuff and they'll buy you a brand new car. Not even for Christmas, just for doing good math. Okay, there'll be a splash. There's also going to be a splash of homework on this stuff, and this stuff is on the quiz. Okay, and now we're going to this rare question again. Entire radicals, where we put everything entirely under the radical sign, and we can do that with cubic roots as well. Okay, so whatever is not a radical, we turn it into a radical or a root. So here we have the 4th root of 3. We need the 2 to become the 4th root of something. Anybody know what it is? So you just multiply 2 times itself 4 times, or again, go to your calculator and you press 2 exponent 4. That's 2 times itself 4 times. 2 exponent 4, 2 to the 4th. And what is the answer? 16. So you convert the number into a radical, and then you multiply the radicals together. So 4th root of 16 times the 4th root of 3. 4th root times 4th root equals 4th root. 16 times 3 equals 48. I didn't do a great job of putting my 4 little. That's kind of too big to be in the index, so I think I'm going to try that again. Just so that the teacher knows, and whoever's marking knows that that's an index, not the number 4 in front of the square root of 48, okay? You need to make sure that looks like that, not like that, because that looks to me like that's 4 times the square root of 48. So careful with your indexes, make them as small as you can, but I, of course, need to read them, so it's a little tricky. I won't be too crazy with that, but it can't be looking like a normal 4. Okay, I'll talk you through this one. We have a cubic root of 7, so now we need the negative 4 to become a cubic root. Okay, so on your calculator, you're going to go negative 4 times negative 4 times negative 4, or negative 4 in brackets, exponent 3. Put it there, and then go ahead and multiply those numbers together. I'll give you 1 minute to do that. So negative 4 times negative 4 times negative 4 equals negative 64. And then you just multiply those together. You get negative 420 plus 28, and you might get negative 448. If you're good with numbers, you can just do that easy. 60 times 7 is 420. 4 times 7 is 28, and you get better and better at it. the more you do it, and you'll get some wrong. Who cares? At least you're working your brain. Okay, now look what's coming. I want to clap for these algebraic square roots and cubic roots. Dun dun dun. What chart are we going to use for this one? Well, let's do it together. Here's the perfect square chart. There's not going to be a ton of these. There might be one or two. Okay, but you still need to get the process. Perfect squares. Okay, let's make a perfect square chart. What's x times x? Everybody? Pick up, says x squared. Good. What's x squared times x squared? Add exponents. X to the fourth. What's x cubed times x cubed? Add exponents. X to the sixth. X to the eighth. X to the 10th. Whoa! Did I cure your hiccup? Your hiccups are cured. See, I'm a doctor. I told you that. That's the only thing I'm a doctor of. I can cure hiccups. See? Nothing. You're welcome. My doctor fee is $79 and... Oh. Never mind. It came back. Oh well, I cured you for 10 seconds. That's good. Good start. Okay, now when we break these A's and X's and Y's up, you want to take the biggest exponent without going over. Oh, my price is right. Ding, 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 ding. So you're going to take x to the sixth, or in this case, a to the sixth, times a. If there's anything left over, it's always going to be 1a or 1x or 1y. There's nothing, if you have 2 or 3 a's left over, you didn't take the biggest one. Now, this is the perfect square. So what number times itself equals a to the sixth? Well, if you add exponents, a cubed times itself equals a to the sixth. So you just divide the exponent by 2. Okay, so write that down, divide, that's the perfect square. And to get what it is, you divide exponent by 2. And when you do cubic roots, you're going to divide exponent by 3. Okay, does that make sense a little bit? A cubed times a cubed is a to the sixth. And then if you have one left over, a gets you a to the seventh. Yes, sir? Not always. If they're even, good question. If I give you a to the eighth, then it would just be a to the fourth. No radical left over. It would just be a perfect square. And we'll see that coming up in example 4. Good question. Okay, B. Okay, again, look at our perfect square chart. What's the biggest exponent without going over? 8. Okay, so sometimes students want to say t to the fourth here. It's 8. T to the 8th. You're only going to have 1 t left over or none. If it's odd, you have 1 t left over. If it's even, like Raymond said, you're going to have no t's left over, and it's just going to be no radical part. Oh, I gotta step up the scaredness. Okay. I'll turn off the light now. It's good. Okay, what is the exponent now? So what's the square root of t to the 8th? Just divided by 2. What times itself equals t to the 8th, everybody? T to the 4th. Look at these definite car-worthy free cars from your mom and dad answers. They see you doing this, holy moly. And they'll just bow to you and buy you a couple of horses. Now we got a cubic root. Cubic root, these are the perfect cubes in blue. Perfect cubes are x cubed, and then x to the 6th, and then x to the 9th, and the multiples of 12 for the exponents. Okay, again, you got to find which one on the chart is the one that you don't go over. That's the one you use as your perfect cube. So I got x to the 5th. I'm going to use x cubed as my perfect cube. That's the perfect cube. That one turns into the number. Okay, I know it's not a number 2, but if x, square root of x squared turns into x, x is a number. Okay, if it doesn't have a radical sign, it's a number in math. So cubic root of x cubed times the cubic root of x squared, because we need to get x to the 5th. So 3x's plus 2x's equals 5x's. And now, what's the cubic root of x cubed? What number times itself 3 times equals x cubed? Somebody? Someone's at it? X. So x cubic root of x squared is this fun answer. Not Halloween answer, not scary. Christmas answer, like beautiful, happiness, joy, joy. How do you get the perfect cube? Well, you just divide the exponent by 3. Divide exponent by 3. All right, D's even harder than C, but try it anyway. Okay, go to the chart, pick the one that's you don't go over, and then simplify it to a perfect square. Just try it. Cubic root of x to the 7th. This puts something. We are very new to this. To get started, you have x to the 7th. You're going to use the one that's smaller than x to the 7th. X to the 6th. Excuse me. This one we talked about using the one that doesn't go over x to the 7th, so we use the cubic root of x to the 6th, because that's a perfect cube. And then you have x to the 7th, so we have 1 left over. So on cube roots, you might have 2 left over, like we saw here. You can have x squared left over. When I said you'll only have an x left over or none, that was when I was talking about square roots. Okay, cubic roots, you can have an x left over or 2 x's left over, or none. So now the trick is, what is the cubic root of x to the 6th? What number times itself equals x to the 6th? Avery?
X squared.
Good job. That should make sense if we look at it this way. When we multiply these, we add exponents. So what number multiplied by itself 3 times equals x to the 6th? X squared. That's why that becomes x squared. Okay, you want more fun? Sure, good idea. Let's move on to ones with numbers and letters. All right, we're going to do a hard one. So we'll start with C, which is, well, I think D is the hardest. We'll do C and D. And now we have numbers and 2 variables. We just do them one at a time. So just like you did on the quiz, how would you break up square root of 32? You've seen that a few times. What's that? Somebody? The tricky one. Square root of 32? (16 times 2). Remember, 32 and 48 are 16s, and 80. 16 times 5. Okay, now we got to deal with the y. So we're going to deal with this part again, the perfect square chart. So we have y to the 7th. Which one is closest to y to the 7th without going over? Y to the 6th. That's not what we have. We have y to the 7th, so we put the other y in the under the radical sign. Z to the 8th, which one do we have without going over? Z to the 8th is a perfect square by itself. Sorry that I can't write this perfectly. And that means we have no z's in the radical part because they're all in the perfect square part. Next, we square root this. Square root of 16. We know that one. What's the square root of y to the 6th? divide the exponent by 2. Y cubed. Why is that true? Because y cubed times itself equals y to the 6th. What's the square root of z to the 8th? Similar to this. What's the square root of z to the 8th, everyone? Z to the 4th times z to the 4th equals z to the 8th. So again, divide the exponent by 2. That's all we have to do. We just have to bring the radical part down now. And we get the very uncomplicated, simple answer of 4y cubed z to the 4th radical 2y. Triple fun. Okay, maybe it is like Halloween. Little scary. But scary fun. When you get the right answer, you feel great about yourself. Let's do the cubic root. Let's do D. Cubic root of 40. Remember the cubic roots? 2 times 2 times 2, 3 times 3 times 3. And I don't have to go any bigger because our number is 40. So we're going to use 8 times 5. So the cubic root of 8 times the cubic root of 5 gives us 40. X to the 4th. Look at my perfect cube chart here. X cubed is the one we're going to use that doesn't go over. So x cubed as your perfect cube. X, 1 left over x on your radical part, your cubic root over there. Y to the 9th. Ding, 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 ding. Similar to the last question. Y to the 9th is a perfect cube by itself. There's no leftover y's. So we put y to the 9th here, and we're done with that radical. Really? Still hiccuping? Okay. I'm trying to think how I can really, really scare you. Oh, I got it. Cubic root of 8 is 2. What's the cubic root of x cubed? What number times itself 3 times equals x cubed? Well, that's the definition of x cubed. X. And what's the cubic root of y cubed? Similar to the one we did last question. Y cubed times y cubed times y cubed gives you y to the 9th. And then you got to put cubic root of 5x. And yeah, that's even more scary than the last one. That's okay. I'm not going to ask you that one. But I might ask you these. So try A and B. Just try them. Those are square roots. So you're back over to the green ones right here. Okay, these are that's the perfect square chart. Okay, now you're going to square roots with your x's and y's. I'll give you 3.5 minutes to do A and B. Okay, let's tackle this guy. Square root of x to the 6th. That is a perfect square right away. Nice. I'm going to break this up into the perfect square part. That's the perfect square part. Times the other part. There's no leftover x. Y to the 5th. You're going to have to use y to the 4th as the perfect square. And so we have 1 leftover y there. And now you have to square root these guys. So you get x cubed y squared radical y. So cool. Who got that one right? Oh, good. Okay, I like it. That's awesome. Good for you. Okay, I'm going to show you a different way to do B or C or D. You might like it better. I think it's a bit more confusing, but it just depends on who you are. This might work way better for you. So sometimes people, even teachers, will break this up into numbers and variables. Okay, so again, this is like you saw on your quiz just now. So that breaks down to 3 radical 2. And then your x cubed, I see an x squared right here. So your x cubed would be x squared times x. And then the square root of x squared is x, so x radical x. But then you have to combine the numbers or anything that's not a radical together. and the radicals together. So if you want to do it this way, you would put 3x in front of the radical, and under the radical you would put 2x. Anybody get that, doing it the other way? So if you like this way, just write it down and do it that way. If that's less confusing for you, and I can understand how it would be less confusing. But make sure that once you get to this point, you know what to do. You have to put the numbers together and the radicals together. Why did I pause what I said? I don't know. So this one, study, but not much. Don't spend an hour studying it. This will be on the quiz, but just a splash of cubic roots, and this is even less important than the cubic roots. So 1 or 2 cubic roots, maybe one of these. Don't spend all weekend studying x squared, y squared, and how to do the square root and cubic root. Okay, the next thing we're doing is homework for 5 minutes. Okay, let's move on. There's a practice test on page, I think it's 18. Is this 18? Yeah, page 18. You're going to do that over the weekend to help you study for the quiz, okay? So that's not due tomorrow. Just those little homework questions right here. Is your homework. This is still all on the quiz. Your practice test is all questions on the quiz. Now we're moving on to page 20. If we're going to page 20, exponent laws, not on the quiz. So let's write that down right off the bat. Not on quiz. You're going to need to know exponent laws on the test. Let's move all those boxes up. Okay, so let's start by saying, underlining this example and doing this example. When you have 2 bases and 2 exponents, you add exponents. Okay, so write down keep base. What does keep base mean? That means when you have 8 cubed times 8 squared, you don't put 64, you put 8. Okay, the answer is 8 to the 5th, not 64 to the 5th. So keep the base and add exponents. Write that down. Add exponents. And let's give you one more example. That's a little harder. X to the -2nd times x to the 6th. Go ahead and do that. Thank you. X to the -2nd times x to the 6th. Keep the base, add the exponents. Tick, tick, tick. Talk, talk, talk. What do you get? X to the, what's -2 plus 6? 4. X to the 4th. Similarly, when you divide, you subtract exponents. There's an imaginary 1 right here for this A. All this mumbo jumbo is here, is it just shows you why you add exponents. If you have 3 8s and multiply by 2 more 8s, you get 5 8s. That's explaining why you add exponents. In this case, you have 3 8s in the numerator, you have 2 8s in the denominator, they cancel, and there's 1 8 left over. That's why you subtract exponents. Okay, so write down subtract exponents. Excuse me. And this is maybe the trickiest question I can give you, or at least it tries to trick you. So go ahead and do that one. And most of you are thinking, what's the problem? You're not tricked. Here's the treat. You subtract. 10 subtract 5 equals 5. There's a temptation there to divide exponents when you can divide exponents. You never divide exponents. There's not a rule anywhere that says divide exponents. Okay, so either add multiply or subtract exponents, that's it. You never divide exponents. Write that down if you want to. This one, maybe this is what I want to see here. If I give you AB all cubed, you can rewrite it as A cubed B cubed. That's simplified. That's all you can do. So please get those. I'm going to call them fairly easy marks. That's all you can do, but you can't just leave it blank. That's different, and that's getting rid of brackets. That's simplified. Similarly, if you have A over B all cubed, you can put that equals A cubed over B cubed. Okay, so write that down, please. And lastly is the power rule. So underline that and underline that. And put a 6 there. This is different than this one. You have to know which ones you add and which ones you multiply because they look fairly the same. What's the difference? This one has 2 bases, 2 big numbers. This one has 1 base and 2 exponents right beside each other. That's the one you multiply. So don't guess and be happy with 50-50. Know that these are the ones you add exponents when you have 2 bases, 2 exponents, and here you multiply exponents when you have 1 base and 2 exponents together. So write down multiply exponents. And I'm going to say this is what happens, or this is when you have 1 base. And 1 base means 2 exponents together, right beside each other. Now, I want you to write here, except I'm going to write it to the side because I'm running out of room. But the biggest example, and study star this one, please, is this question. 5a squared b cubed, all squared. That's more of the power rule you're going to get. And you're going to have to know the hardest part. Because the hardest part, when I ask you a question like that, I'm actually seeing if you get the number part right. Everybody gets the exponents right. You multiply the exponents. But if I ask you this question, I'm more interested to see what you put in front. The rule, the exponent rule, is to multiply exponents. This 5 is not an exponent. It doesn't apply to the exponent rule. You do not put 5 times 2 equals 10 there. This is a base, and this is an exponent. 5 squared. What's 5 squared? Whoa, that's not it. 25. So put not 10, because honestly, I might see 10 more than I see 25. You do not multiply numbers with exponents. You only multiply exponents together. This is 5 squared, base and an exponent. 5 squared, that's what 5 squared is. 5 times itself 2 times. 25. Okay, so watch it. This is going to be probably half of your marks when I mark this question, because I'm looking to see whether you get the number part right. All right, do the next example. Try those 3 your best. Figure out when you add exponents, subtract exponents, multiply exponents, you never divide exponents. Okay, A. You add or multiply exponents? Everyone? Add or multiply exponents? First of all, keep the base. Don't put 9. Put 9, you get all your marks wrong. Keep the base. 3, base is 3. The big number, keep the base. And then, like you said, add exponents. That's different than C. B, subtract exponents. Why is that wrong? Good job. You have to put brackets. So study star this. I don't care if you put brackets now, but on the quiz you have to put brackets because that's a different value. Otherwise it's not the -2 that's being squared, it's just the 2 being squared with a negative sign out in front. Okay, so write yourself, keep brackets, or just brackets, exclamation mark, that's a study star, so you don't forget when you have a negative base, you need to keep the brackets inside the negative signs, because it changes the value when the exponent is even. C, multiply or add exponents. This is when you have two exponents right beside each other. So 2 times 3 is 5 to the 6th. Now why are all those answers not full marks? You would notice it says evaluate. So most times those are going to be full marks for me, but if it says evaluate, that means find the value of, you actually have to punch 3 to the 6th in your calculator. So go to your calculator. Again, that's the exponent key that you need to know and press many, many times in the next 3 years. This is the exponent key. So 3 exponent 6, everybody. What do you got? Big number, sorry. 729, thank you. Oh, what's that? 81 times 9. And this one is -2 times -2, so that's just 4. And then what's 25 times 25? 625 times 25 is what? What's 5 to the 6th? Somebody? 5 exponent 6, you're done. Well said. Thank you. Okay, next 6 minutes, you guys get to do all these. Okay, finish example 6. See whether you keep the base and add the exponents. When you have 2 bases, keep the base and subtract exponents when it's division, or keep the base and multiply exponents when you have 1 base and 2 exponents beside each other. Take a peek at this one. Where'd it go? Where did it go? Oh, here it is, K. K is like the one we did before we left the chart. Okay, so this K one is not 2 times 5. It's 2 to the 5th. 2 exponent 5 in your calculator or in your big fat brain. God, that's an awesome day!